universe is true. We have scientific evidence. Look into flat Earth and learn that is flat. But we are the main event. You are in the center of the universe, brothers and sisters. Remember that and keep it in your brain.
We're headed toward Windover, Utah, near the Nevada line. This ancient lake bed is so flat and level that you can see the curvature.
The Bonneville Salt Flats. Unique, dangerous, a strangely brutal and very beautiful land.
And what it is nothing. It's just flat, big, flat salt.
Well, a funny thing happened on the way to the moon. That's the title of a video that I watched on YouTube. You can see astronauts hanging from wires, proving that astronauts and NASA are liars. They analyze photos and highlight mistakes with the moon landing missions. They show it was...
Are you guys keep flashing. I'm seeing that.
I'm just trying to see where to look. I want to see where the ether band is near.
Oh, yeah.
We're losing this whole area right there.
Yeah.
We're seeing a lot of miraging happening.
Does it block it enough we can actually see?
Oh, yeah.
Okay.
But there's an ether band. This was moving. There was something here.
Oh, yeah, because that's the that's like the that's like a miraging effect happening that you normally see over the dry surfaces.
Well, but no, but there's something on to the right of that, to the right here, like this. There's a brown blob there. It's
right, I see it.
There's something. I don't know if there's something standing there or
Hold
what.
on.
But
Well, where is the Utah tree? Is it not on this road?
it's over there on the other.
It's on that side?
Okay, that's not there.
Yeah, good question. So do we want to maybe angle it down a little bit
Yeah.
and see?
Yeah, make sure it goes up in the air too, because...
Up in the air and side to side.
Okay, rolling.
So we're at the Salt Flats and we are doing an observation, a mirror flash, of a distance of 35.6 miles. Sydney Silver is down at the west end and we're down here on the east end, and we're going to be flashing mirrors. And over this distance, you shouldn't be able to see any straight line mirror shots because there's going to be a huge bulge in the middle. Could you do like some jumping up and down for us? We're trying to see if we can see you in this P900.
Okay.
Could you jump up and down for us? We think we got something, but...
Jumping.
Can you see it?
Do you see any mirror flashing?
No.
We don't see any mirror flashing yet, so... And we don't see you jumping.
There's major ether band happening.
There's a major ether band happening. We're getting some miraging.
My name is Ryan Walker. My flat earth journey Flat Earth journey probably came to a head in 2015 at some point. I don't have that mark of day that it actually happened, but I know the journey it took once I got it into my head that something's not making sense here. And then I researched it. It really came across with the curvature for me. The curvature, or lack thereof, after studying what it should be and how it should be detectable very easily. I was a software engineer, and we did a lot of distance calculation, geomapping and geopoint mapping. So I started playing around in my head with how we made calculations of point-to-point distances because we had to map real estate properties. And it just started not making sense. And the big realization is we can see much further than we should be able to see based on the actual distances they tell us we're seeing at. If you see a boat go over the curvature, you can't see it anymore because it's gone over the horizon, over the curvature. To measure when that actually happens, you can put a formula to it scientifically based on what? The circumference of the whole globe. The calculation of 8 inches per mile squared of curvature, okay, calculate that by 3 miles, that 6 feet, 72 inches should be over the curve. You should not be able to see them. What we actually see is the way our eyes work. We see in perspective. And everybody knows this. If you've taken any art classes, you understand how perspective works. You can draw a picture based on perspective because everything goes to a vanishing point that our vision can't, you can't see any further than that. But now with technology that everyone has access to, you can take a zoom camera. I have a Canon 7D. You can zoom in on something, bring it right back into focus. It's not just past 6 feet, it's hundreds of miles. That either tells us their calculation of a 25,000 mile circumference of the globe is inaccurate, or it's just false.
I feel like the sunlight's very dim.
It does feel that way, Sydney. I agree.
Yeah, I've never really seen it work when it's like this.
And they're spraying all this chemtrail stuff. It's like, it's kind of inhibiting some of the...
Yeah, it does look a little hazy and it's a dim sun.
We're going to wrap up and then we're going to come back and shoot the lasers. So since there was some interference in the road, it's inconclusive of what we actually captured. We're going to go back and look at our footage and see what we got.
Well, my flat Earth journey began in the year 2015. This guy says this is a compilation of ideas from the flat Earth theory. So we're watching this time and time again for the whole weekend, you know, from Friday night saying, did he say flat Earth, to around Sunday evening, we're like, pretty sure the Earth is flat. The initial response that I got was pretty much what everyone gets when they discuss flat Earth. You know, you're crazy. Are you kidding? You did graduate from school, right? Have you heard about gravity? Things like that. These kind of condescending tones that people take with us. You know, I would ask people if they ever actually felt the motion of the Earth. You know, if they knew what the circumference of the Earth was and the formula to calculate the Earth's curvature. I would ask them those questions, and more than half of them had no idea. There was one experiment or observation that I did with a friend of mine from work, and he comes to me one day and tells me that he has a laser that has a range of 12.5 miles. And we ended up finding 2 places. One was in Owen Beach in Tacoma, and another point was at Saltwater State Park in Des Moines, Washington. Over that stretch of water is 10.3 miles. And I was doing a live stream. I had about 150 people on that in the chat. And we were on the phone with each other across the water, and just as clear as anything you've ever seen, we were able to see the origin source of that laser due to the lack of curvature. It was obviously direct line of sight.
10 miles away, right? Yep. That's 10 miles away, folks. Boom. There it is.
Why suspicious? So, do you still believe we went to the moon? Do you still believe what they're telling you? Just connect the dots and pretty soon you'll find out what I found out too. But if you question this stuff, you'll be labeled a loon. You'll be called a conspiracy theory buffoon, but I don't care, man. I'm still gonna make this too, cause I know that we didn't go to the moon.
Why don't you swear in the Bible that you walked on the moon? You're the one who said you walked on the moon when you didn't.
So I'm not trying to get from me to there.
Right.
I'm trying to get the distance from the ending of that mountain.
Okay,
to
got
the
it.
beginning
Okay,
of that
sure. Okay,
mountain.
Sydney, I'll do that.
Yep. And then from the ending of it over there, because I got a shot from there to there. Okay, but how long is that
To that.
Okay, well then this is, just take that off there.
So we're trying to figure out the distance from this mountain range to the
that
base of that
mountain
mountain
range,
range, right?
and
I believe this is
that
the
mountain
two mountain
range-
ranges you're talking about. See, from here to here, right?
So we just got 24 miles.
Oh, get a
Yeah.
copy. Can you get a screenshot of that?
So what we're looking at is behind us. There's 2 points with the mountains between the mountains we can see with our naked eye. And it's 24 miles basically.
And Sydney got a picture
those
of
2
it.
points. Yeah.
Okay, I just took a picture of the horizon.
Yep.
And between that mountain and that mountain is 24 miles. So there should be a huge curvature right here, but we're not seeing a hump and we're not seeing the edges bend down. It's completely flat. So I just snapped a picture from there to there. And we got the mileage on it. So you can do calculations on the...
I go by J. Tolwan. I'm an engineer, RF. Also did other stuff, mechanical, physics. Right now I'm an electronic warfare engineer. I support defense contractors. I was at a classified meeting one time and I saw a map projection that I had never seen anywhere else. And that was in the early stages when I began to wake up. And I realized what's going on. Then I seen some very strange data that I was processing from a classified payload, and I realized, oh my God, whoa, something's strange here. Since I'm an engineer, I said, I'm going to measure the curvature because it's a fun project, something I've never done, and I'll show everybody how it's done.
What got you into photography and specifically infrared photography?
Well, so I quickly realized that I need to see farther. Right, all the measurements that I had seen in other videos, they're at sea level and they're just a few feet, 100 feet, maybe a few miles out. And I realized, well, we got to see a lot farther than that. When I realized I couldn't purchase any of this military-grade equipment because they're ITAR controlled, I decided to try a night shot camera, and I had one like 20-year-old camera. So I came out here one time, just out of curiosity if I can see a little farther. And I was just blown away. I could see the mountains behind us out there. And that's when I got really excited and I said, okay, I gotta purchase better equipment. So then I ended up purchasing, I don't know, like 3-4 different cameras, including this one and the 4K camcorder. When I looked out east, that's when I saw San Jacinto and the other mountains, Mount Baldy and the Arrowhead mountain, and I was just blown away. So on a clear day, you can see, I don't know, it could probably double the distance. On a clear day, let's say you can see 80 miles, like right now you can see those mountains. You could probably see 160, almost 200 miles if it's really clear. And the best time is in the winter time when a lot of moisture is condensed, and the atmosphere is clear and dry. Then you can see the farthest in infrared. So by seeing farther, right, now you can have more conclusive measurements of what's hidden behind the supposed curve, right? And you can do more precise experiments with a higher confidence level than otherwise. Longer distance translates to more conclusive calculations of, the curvature, if there's any curvature. I went on top of Mount San Jacinto, took the tram up there, and they have a plaque up there that says on a clear day you can see Mount Charleston for about 175 miles away. From Fraser Mountain, I saw about 185 miles. And from White Mountain up north, I saw some land features towards Colorado, which I think are close to about 200 miles away. A lot of my coworkers, they're listening, they're interested in science if you present it correctly, but then they also go along with the jokes and stuff. I have a bunch of jokes taped to my to my office. Even the birthday card that I got, they took some flat Earth jokes and they posted on there. But some are very interested and they know what I'm talking about, and some have corroborated from their work what I had seen.
Okay, so the plan right now is we've got the lasers put on the tripod. We've got two of them, the blue and the green, and we've got them sort of both pointing the same direction. And I'm going to walk down there, leveling a laser. The bubble laser the bubble level just doesn't cut it for any distance at all. So I'm going to try and walk down there maybe 50 yards or so. And I know the laser is right about here on me, and I'm going to see where it is out there, where the center of the beam is out there at 50 yards. And that'll be pretty good. And we go down, by the time we get to a mile with the car, then we can see if it's still about the same height or if it's up or down. We'll be leveling it all the way down there. So we're just in the initial leveling right now. I'm going to paste it out here.
35 miles away the other end?
Yeah.
Can you see me now? Hear me now?
Oh, is he blue? Wait, oh, there. Yeah, I got it. Right there.
Oh, yeah. Oh, yeah.
Whoa.
There. Now turn it. There. Hold right there. Right there. That's it.
Yeah.
Don't move it. That's it. It's right in our eyes. Beautiful.
All right, 5 miles.
Okay, we're at the 10-mile mark after a little hiatus there. So this is showing 10 miles, and there is the altitude 4206, so it's very close to what we were, and the date and time, and of course the coordinates of ground positioning system.
There it is. Yeah. That's
10 miles down. Oh no, that's good.
10 miles, got it.
10 miles of laser.
Yep.
Right in my eyes.
Yep. Very bright. All right, 10 miles. Fire it again. Is that there?
That's a
yep.
blue.
Oh yeah. Look
oh,
there.
Yeah.
Yep.
That's
okay. Do it again. So this is great. We got a two-way blue. Oh, you see the blue and the green?
Yeah.
It's beautiful. Is that picking it up on that?
Oh yeah, definitely.
It's you can see it better even with the eyes. It's just so beautiful.
Oh, it's way cool. It's totally
freaking
clear.
Beautiful. Are we getting video on what we're doing here?
Yeah. You can see
sound?
you. Yeah. There's
okay,
sound.
Cool.
There's sound. You can see
this
you.
This is great. 17.5 miles, man.
Yep.
Setting up at 25 miles. Here is the altitude showing 4221. Okay.
Tell him to turn it off.
25 miles. Turn it off?
Yeah, I just
turn it off.
Turn off the laser. Yeah, I just want to make sure that's.
Turn off the laser.
Wait, which? Turn it back on.
Okay, go back on with it. Okay.
Oh!
There it is.
I'm trying to see what you're seeing. So
that white light is really throwing me off.
the big white lights on the freeway are throwing me off.
Yeah, well, okay, we got the blinking tower, and we have the red lights beside it. They're to the left of that.
See, look how it's purple. I think we see you guys. Oh, that's them.
Okay, we're gonna try to lock you on then.
Okay.
So you have to tell us when you're.
We got it. We see you guys. There it is.
This is Shelley's position where we were seeing the laser from. That's the exact GPS, and the odometer. And from us, it says 35.5.
Yeah, you're right. You're right close to the red lights.
Yep.
Yeah, we got it.
Do two together. Can you do two together, David?
Yeah.
You see it? You see it?
Yep. Oh, there it is. Boom. Just leave it right there. We got it. We got it. Just leave it right there. Right there. Yep.
One of the rebuttals that we get from the heliocentric enthusiasts, the globe believers, is that we didn't account for refraction. The argument that was used was that the air temperature and the water temperature would differ and cause the laser to shift, you know, the end of the light to shift, and said that that was actually you know, due to refraction, and it was possible for us to see the source of the laser from that distance because of refraction. But looking into what refraction really is, the definition is when light passes through a medium that causes the light to move slower, passes through a medium. Now, we didn't pass it through a different medium, and if you Google refraction, you'll actually see lasers firing into water, and they'll go in at one angle and then bend and come out at another angle. The only thing is the water was level and the laser was parallel to the water, so it's pretty much invalid.
7 feet off the water. About 7 feet off the water. Okay, so here, I'm gonna lean down a little bit. It's like the tide's coming in. So hold on. Let me back this thing up a little bit. The water's coming in. Yeah, we're on the ground right now. 10 miles away, huh? Do we need to get into the water? Let's get into the water a little bit, huh? Oh, look, people. Hold on, we're in the flipping water and you can still see the laser.
One of these folks, if they're standing in a room or in some area, a coliseum or something, they see a red dot on them, they're gonna get out of the way because they know that that laser pointing at them is going to fire a bullet straight at them, and they're not gonna say anything about refraction and just say, forget that, it's never gonna happen. But they like to make these adjustments only when we're using these arguments to prove flat Earth.
What we're doing is we're going to be taking the lasers and we're going to shut them down the tracks and see if they can see them at the other end.
Excellent. Let's see. There we go. All right. And tell us where you're from.
I'm from Nigeria.
Okay.
A city called Jos. Just a couple of hours drive northeast of capital city, Abuja.
Okay. Very nice. And so you're on this observation. You drove all the way from Denver.
From Denver, Colorado. Yeah.
That's great. Well, we're excited.
Awesome.
So we're documenting this
too.
day. Today is Friday, January
24.
And it's approximately 8 p.m. So yeah, we're excited about this observation.
So I'm going to just shine it just so that we can see what it looks like. So that's the green laser right there.
All right, everybody look down there. Anybody see what color? It looks like I see blue. Do you guys see blue? I see it. I freaking see it. David, can you get it on camera?
Battery shot.
Why are they not working?
It's the cold weather that's doing it.
My camera's not working.
Like, hold it in the pocket.
It keeps saying battery exhausted.
Mine too.
Wow, it's weird.
Put hand warmers, tape hand warmers.
Okay, David, can you go put tape hand warmers on them, please?
Where's the other battery? Did I give it to you?
Yeah.
My battery got exhausted too.
Yeah, and mine's are brand new. Mine are brand new batteries. They're fully charged.
Wait, just tell me when you're seeing it.
Okay.
Put at the same length as the same as you did. And what we're doing is we have a hand warmer on the bottom of the battery. It's working.
Father, make this battery last, please.
It's off to the left here, quite a bit.
Is that this one green here?
There it is.
Yeah.
We saw it. You see it?
I was doing the round.
We saw it.
Oh, there it is. Boom. That was a big one. Yeah, oh, there it is. You're really nailing it. You got it really nailed it.
I got it on the camera. I got it on this camera.
Yeah.
Got it.
Yeah.
So got it.
We got it. You guys hear us?
Yep, got it.
I see it.
There it is. Yeah.
Those hand warmers actually worked. That was an incredible idea. That was a good idea.
That's the actual altimeter as opposed to the GPS reading 4239. So that's very close.
Very close.
Okay, this is the location of the lasers. They were up on these tracks here. We had 2 tracks there, but it's just a side track up there. And right here is the direction that they were facing. And they were shooting the laser that direction. And now we're all over here.
So we got a major flat cuisine going on here. Whatever you're making up will be totally fine, Sydney. Yeah, like it's totally good.
Okay, all right.
Like amazing, yeah.
Yeah, I don't have any specialty. Right, it actually does taste better kind of when it's on the fly like that.
Oh, absolutely.
Right?
Absolutely, yeah.
I've never
Awesome.
seen this.
Okay, so tonight's test, when we were doing the laser test, we were at the 35.8 mile mark, and we had a P900 and the Raven camera. And what happened was when we were doing the test, because of the city lighting, there was too much background lighting. So we're going to be flipping the test tonight to be able to get the laser test again without the background lighting that's in the way.
Oh, I see it. Green. You just shined it. Yeah, you just shined it. I got it right here.
Okay, so you guys can see it, is what you're saying.
Yeah, look, right there. Clear as day. Clear as day. Got it. Yeah, there it is. There it is. We got it. We got it.
Randy is the bomb.
People just are focused on one area of science. You know, I was fortunate enough to bounce around between different jobs. I worked for like 6-7 different, defense companies, and even the job that I kind of hated the most was a job I had at Vandenberg. I worked on the Minuteman intercontinental ballistic missile. I was an RF engineer, and I just wanted to get out of Las Vegas. I got tired of the heat. So I went out there, and I didn't quite like the job. Kind of boring. You lunch once or twice per year, and most of the time you're bored out of your mind. But looking back, now I realized, oh my goodness, there's flat Earth clues all over the place. I used to live in Florida and work close to Kennedy Space Center, and I've seen so many launches, the space shuttle, take off at night during the day, land a few times, rockets. And at the time, I wasn't aware of the flat Earth phenomena, But now looking back, it's like, oh my goodness, it's embedded everywhere. And basically science just says there's refraction. That's their only answer. Oh, there's refraction. That's why you're seeing it halfway around the world. Yeah, exciting location, Malibu, California. And we're watching mountains in the distance in infrared. This is a converted infrared camera. I can see Mount Baldy about 70, 80 miles away. And I can see the Arrowhead Mountain barely because it's got snow on top. That's at about 115 miles. But Mount San Jacinto, right now, I cannot tell if I'm picking it up or not. Later when I go home and I process the information in Photoshop, sometimes I just contrast and I spot it, but we can at least see something in the distance. And usually the cloud cover, so there's a slight cloud cover that blocks the infrared light from the sun. So the mountain could be in an infrared shadow, but the other ones show up, so that's great. So lots of cool stuff. It's exciting to be able to see that far, right? 123 miles away, mountains that shouldn't be visible, you know? Now that I've lived this reality for a while, you know, it's not as exciting, but when you first hear about it, it's like shocking, you know? So I went through my, paradigm shift about 5 years ago with everything. Kind of just boom, 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 like a domino effect. And I realized, oh my God, we're like under a dough. I'm some other, shaped in a globe.
I told you so. I told you so. I told you so. I told you so.
It's Shelley Lewis from Down the Rabbit Hole. I'm with my guest, Sydney, and she is a fellow flat earther. I love Sydney. She's so awesome. Okay.